board. I'm going to share, make sure that everybody gets all the information. Can everybody see this? Okay. Even though it's Monday, things seem to be working. Let's say that, knock on wood, right? As soon as you say it, so confidence intervals, we have been doing them all of last week pretty much. Now we're going to be doing them with the student T or with the degrees of freedom. How this makes a difference, and there's only really two differences. If you look at this, there is the formula to the right. The formula looks very similar to the one we were doing before, except for we had Z alpha 2 and we had population. So I'm going to draw that above so you can see. When we were doing our confidence intervals with this is known, we had our point of estimate plus or minus our Z alpha 2 times the population standard deviation over the square root of n. Now, in these problems, S is going to be known, and S is our sample standard deviation. So sample standard deviation is now going to be given in the problem, which means that we need to approach them a little bit differently. It means that we need to find different information. There is not a handy dandy wonderful chart for T alpha. I'm sorry, there just isn't. So when we find the T alpha, we're going to be doing it. Well, there is a chart, but not one that's as convenient as the Z alpha. Okay, so we're going to find this now with invert T in the calculator is how we're going to find the T alpha 2. This is the sample standard deviation. Okay, n is the sample size, and x bar, which is the sample mean, are still going to be given in the problem. So the only thing that's changing is we're finding a T alpha 2 now, and we are putting in the sample standard deviation instead of the population. But our calculations and how we solve them and what they mean and how to evaluate them or interpret them are all going to be the same. So nothing is changing with that. Now I do want to show you the T distribution. The T distribution is necessary when the population standard deviation is unknown and the sample size is small. But nowadays, it's pretty much used all the time. Normally, if n is less than or equal to 30, we consider it to be small. We've talked about this before. N does not have to be less than 30 for us to use this. And here is a visual of the T distribution. So it depends on the sample size, the degrees of freedom. Now, this is the new terminology that we need to learn today. DF is degrees of freedom, and it is always one less than the sample size. So degrees of freedom is one less than sample size. And the formula for it is n minus 1. I don't like the fact that those ones look like eyes, so I'm going to doctor them a little bit, okay? Maybe. Make that look like the number 1. Okay, so if you're looking back at this, it'll be clear.
Hey, Ms. Bermati.
Yes.
Is our test going to be on Thursday?
Yes.
Okay. Thank you.
Yes. Nope.
Is it okay if I ask you something after class?
Of course. I'm always available after class. So the mean is still 0, and you're still symmetrical about 0, except for now, since the sample size is so small, then they have a shorter normal distribution, okay? So it's as the degrees of freedom get larger, so does the peak. And we assume the population is normally distributed. The meaning of T alpha 2 is similar to the meaning of Z alpha 2, so that's not different. Now, you will have the chart, okay? And I'm going to show you an example of that real quick. It's going to give you the chart in the problem, and I'm going to tell you to not use the chart. I will show you that we can use the chart, and I'll show you how to. But I'm going to ask you to use the invert T. And the reason I say that is because when you have a confidence interval chart, it's for the T, it's actually really large. It's much larger than the one for the Z alpha. So I'm going to show you now what Newton would look like for this. Okay, so here's an example problem that you would have on Newton. And they will give you the degrees of freedom chart in the center, and it would give you the margin of error for the 95% confidence interval. It gives you the confidence level of 95%, and you would have to come up with the margin of error for this. So, do you recall that if the confidence level is 95%, what is alpha?
Is that the C value? Like the 1.9600?
Almost, we're gonna get to that, yes, but this is the kind of a step before that. If confidence level is 95%, remember the alpha is the complement to that. What is the alpha?
20.25 or the Z 0.25, 0.025.
Oh,
No.
5%.
yes, 5%. And I just wrote a big slash because I was trying to move stuff. You can't see what's happening on my screen, but it'd be the 5%, and then it would be to the 0.25, like you were saying, Eric. Okay, so you were just one step ahead of us. Okay, so we have 5% because that's the alpha, right? So if we want T alpha 2, right, it's T of 0.05 divided by 2. So it'd be T of 0.025. Is this ringing a bell? We did this with the Z alpha, but we were able just to go straight to the chart. Okay. Do you see T of 0.025 on here?
Yeah.
No, we see it right here, don't we?
Mhm.
Okay, so we have this whole column that I can look at, right? But now we have DF, which is degrees of freedom. Okay, degrees of freedom is what?
The n minus 1.
N minus 1, exactly. And what is N in this case? I didn't read the problem.
17.
17.
Mhm.
So minus 1 equals 16, right? So I would look for 16 and I would see where they match up. And I would get my T alpha 2 value to be 2.120 from the chart. Now I'm going to show you how to do that not using the chart and using invert T. I am going to write down our degrees of freedom because I need to know that for the 16, and I need to know that the confidence level was 95%. Okay. Okay. There we go. Can everybody see that?
Yeah.
Okay, I showed you how to do this last week with the invert norm. There. Okay, remember when we did invert norm for it? And it had area. And it had mean and it had standard deviation. Is this ringing any bells? We're gonna solve it the same way that we do this, except for now we're gonna have area and we're gonna have degrees of freedom.
Mm.
And I will show you what that looks like on your calculator, just so you can understand where we're going. Okay, so if I'm on a calculator, second VARS, I see my invert T, and I hit enter, and it wants an area and it wants a degrees of freedom. Okay, those are the only two things that I need to plug into this to get the T alpha 2 score. Now, the area we have to do in a certain way. Okay. So area equals 50 plus the confidence level divided by 2. $50 plus, what's our confidence level for this problem?
0.95.
95, right? Divided by 2. So we get 97.5. Can I leave it like that?
No, actually, yes.
What do we have to do for the, what do we have to do to the percent? Because this is a percent.
Oh.
Decimal.
Yeah, we moved the decimal twice, right? So 0.975 is what we're actually going to be putting in for the area.
So could you have changed it before dividing it with them by the 2?
If I change this to a decimal and this to a decimal, it should work.
Sorry,
Yes.
y'all. I've been processing this out loud.
No, you're okay. So, but that's a good question. If I had changed both of these to a decimal before I divided by 2, yes, you could do that. Okay. But you would have to change both of them. So that's why I leave them as the whole numbers. Okay. So change to decimal. And what was our degrees of freedom? 16.
Mm.
If you have to write it out by hand, it's invert T area degrees of freedom. Sorry, you can't see that. Let me make this larger so you can see. See my carpet and my writing. And you should get 2.11905,285. And they want these rounded to 3 decimal places. So it tells us up, calls us up 120, 2.120. Is that the exact same thing that we got from the chart?
Yes.
Yes. So either way, you're going to get the same thing. Okay. I recommend doing the calculator way just because in the future, you are most likely not going to have a T distribution chart on hand in your back pocket, but you might have the calculator. Okay. So I suggest that you find this. So we have one major piece of information now. We have the T alpha 2. Okay. Now I'm going to go back to the problem. And all my annotation from before is going to be gone. We're back to the problem. We also need to write down the other information that we have in this problem. So suppose that the number of people employed by an individual business is normally distributed with an unknown mean and standard deviation. A random sample, n equals 17, business is taken and gives a sample mean, x bar is 15, and a sample standard deviation, S, of 2 employees. Find a margin of error for a 95% confidence interval.
We are not seeing your,
You're not seeing this screen? Oh, not my handwriting, I'm gonna show you in a second. but Can
Oh,
you see
okay.
the problem as I'm talking about it?
Are you ever gonna subtract it?
No, for these you do not subtract. And the reason why, Eric, is because if I subtract it, it gives me the exact same value but negative.
Oh, okay.
Okay, and hold on. Excuse me.
Bless you.
Thank you. Ooh, that addition, the positive and the negative are built into the equation because when we say X bar plus or minus, this is the plus and the minus is already built into the problem. Does that make sense?
Yeah, I see that now.
Okay, so we don't have to subtract it. We just have to find the positive, which gives us the margin of error. And when we add and subtract it from it, we get the right answer. Okay.
Thank you.
So I have my N, I have my sample mean, I have my sample standard deviation, which in the calculator would be SX. Okay. SX, we're gonna get to that just so you can start to see it and have it in your notes. The confidence level is 95%. The margin of error is equal to T alpha 2 times S over the square root of N. We found our T alpha 2 to be 2.120. We can find that on the chart, or we can find that in the calculator. Our sample standard deviation was given to us as 2, and our sample size is given as 17. Now, notice that the degrees of freedom is used to find the T alpha, but the sample size, the original sample size is used to find the margin of error. So please don't make that error. And what do you get when you multiply these together? Multiply and divide.
One 1.028.
And I wants it to 2 decimal places, so 1.03 is what our answer will be. Did anybody not get that or need me to show you on the calculator how to get that? Okay. Now that's our margin of error. Correct. Now, if you notice in Newton, it shows you how we got all of the information, right? It shows you the exact same process that we just went through, okay? And then you hit continue. And now it asks you for the confidence interval. It uses the exact same information from above, but it wants us to give you the confidence interval. Do you remember how to find the confidence interval once you've had the margin of error?
Is that when you do the mean minus the marginal area? I mean, subtract the marginal area or plus?
That is exactly correct. Okay, so we take the mean minus the margin of error and the mean plus the margin of error. So in our problem, our mean was 15. Our margin of error was 1.03. mean plus margin of error. We just plug in the values that we have. Sorry, you can't see that. I'll move this guy. And we have our margin of error. Now, I'm going to write this down so we can see how it's worded. We are 95% confident that the true population mean is between 13.97 and 16.03. Sorry, I ran out of space. I'm going to write it up here so you can actually see it. Is between sorry.
Is there any way that you could enlarge the visualizer? I just wanted to take a picture of that whole page.
Sure. Yeah, I don't know if I can get the whole page in, but yes, I can make it larger. Hold on.
Oh wait, you said that you put these up, right? These notes.
I do, yes.
Cool.
Yeah, but here, if you want it, I can get you as much as possible.
Thank you.
That should give you most of what you need, right? There, does that work?
Yep.
And then I can go up to the top too. But yeah, these notes will be up after class. I think Abby likes them.
Thank you.
And I always feel like it's good to have something to look back on. So. Okay, so you've seen the whole process from start to finish, okay? And you've also seen how it relates to Newton, okay? We're gonna do some other problems that aren't in their format just so you can see them. And then we'll come back and do one more. So let me. I mean, if I'm writing them out, they're more than welcome for you to have them, okay? Okay, so let's go back to the PowerPoint. We have talked about the charts. We've done the invert T. I'm going to exclusively do invert T moving forward. I'm not going to use the charts. Feel free to use the charts when you are in Newton if you would like to and you're comfortable with them. Here is the confidence interval with T. Now that we can find T alpha 2, we can find the T confidence interval. And then it just talks about margin of error, which these are all things that we've talked about. So let's look at this problem. Again, here is an embedded video of it to look at if you would like. Okay. A potato chip company wants to evaluate the accuracy of its potato chip bag filling machines. Bags are labeled as containing 8 ounces of potato chips. A simple random sample of 12 bags. So N equals 12. I'm going to write that down. Had a mean weight of 8.12 ounces. So mean 8.12 with a sample standard deviation. So it said sample, so I have to put the S 0.1. Remember in the calculator, that's S of X. Construct a 99% confidence interval for the population mean weight of bags of potato chips. Find ME, the margin of error, and find the confidence intervals. So the first thing I need to do is find my T alpha 2, which I find with invert T, which is area and degrees of freedom. I need to locate the area. Every time for the area, I say 50 plus the confidence level divided by 2. In this case, we have 50 plus 99 divided by 2, which equals 99.5. And then I change to a decimal. 0.995. Is everybody with me so far? Okay. Well, I also need degrees of freedom. What's my degrees of freedom for this problem?
12 minus 1, which will be 11.
11, exactly. And I got that by 12 minus 1. If I put this into invert t, what do I get for our t alpha 2? You guys want me to show you on the calculator? Okay.
Please.
So I go to second VARS, because that's where I was going before for invert norm. Do you guys see in INVT or invert T? Number 4. 0.995 was our area. 11 was our degrees of freedom.
Hold on, wait, I lied with my nod. I don't see it. I got my number
Okay.
4 is T.
You have a TI 83, so you won't have this. So I'll give you, oh no, you have the 84.
Yeah.
Are you in second VARS?
Yeah. Second VARS.
My calculator has had a hard time working no matter, despite following the directions too. And I have a hard time keeping track of all of the calculator websites that you
Right.
post available for those without access. I have a hard time keeping track of which one is for which.
So Rafe, a
Sorry.
workaround for that is if you go to Blackboard, instead of just having the sites in your browser, on Blackboard, I have them labeled, like which ones you should use them for.
Oh,
Let me think.
oh. I don't want to hold up class anymore.
I was trying to find a
Sorry about
workaround
that.
for Henry, there should be a workaround for you. There's gonna be something at the end of the class that'll make it so you're able to do it, okay? I
That's
promise.
fine. Yeah, I'll just roll with it at this point.
Okay. Did anybody else not get that answer when they entered it in? Okay, so 3.106 should be your T alpha 2 value. Now, what do we do once we find that? Now we have our T alpha 2. What do we do? What are we trying to find?
Find a margin of error.
Trying to find the margin of error, exactly. And we know margin of error equals T alpha 2 times S over the square root of N. So we have our T alpha 2 value. We can plug that in, right? 3.106. What is our sample standard deviation?
0.1.
Yes. 0.1. What is our sample size?
12.
12. I can enter this into the calculator just like that. 3.106 times 0.1 divided by the square root of 12. And what do you get for your answer?
Okay. 0.026.
Something's off with that.
Okay, let's see.
Anybody else?
3.106 times 0.1 divided by 12.
1.08. Well, it's 7.5, but is that not right?
Yeah, 0.0.
I got 0.8966.
Yes, 0.89. Don't forget that 0 in front because that makes a big difference.
Oh,
So 0.08966, and if we're rounding to 3 decimal places, then we get 0.090.
oh, I forgot to square it.
Yeah, I did it like 3.106 times and then parentheses 0.1 and then square root 12 and then parentheses
don't
on the
forget-
outside of that.
You gotta put divided by.
Oh, yeah, forgot. Thank you.
So Eric, when you divide it by, does it give you this answer?
One second, I'm putting it in.
Okay. I'll show it on the calculator just so people can see it. Let's see if I can share it at the same time as everything else and have like a whole bunch of things on. Okay, so we do 3.106 times 0.01 divided by the square root of 12.
I got it.
Oh, I did points. I messed up that time. I did 0.01. Or my fingers messed up when they were putting it in. This should be your answer. 0.089662498. Perfect. I'm seeing Henry's. Okay.
I like to put the parentheses to feel safe, just in case.
Yeah, that's fine. Yeah. Whatever your comfort level is. So this is the margin of error. So if I was doing my problem, this would be my first answer. The margin of error would be this. Then I would continue. Okay. And I would find the confidence interval, which is our mean minus our margin of error and our mean plus our margin of error. What was our sample mean from this problem?
8.12.
Yeah. 8.12 minus 0.09, 8.12 plus 0.09. So we get 8.03 and 8.21 to be our confidence interval. And we are 99% confident that the true population mean is between 8.03 and 8.21.
And this is the population mean versus the standard deviation, just because the
Right.
two. could-
Well, so every time we're doing confidence intervals, we are predicting the true population mean based off of the data that we have. And in this case, we are given the sample standard deviation. That's why we have to find the T alpha 2. If we were given the population standard deviation like last week, we would be using the Z alpha 2 little chart that we wrote down last week.
Yeah, okay.
Okay, yeah, oh yeah, we do the different thing on the calculator.
Right,
See
and
it.
you don't have to do you can just use the chart for it, and then you plug in what this value is. So if sigma, the population standard deviation, is known, then we do Z alpha 2, and we plug it in from the chart. Okay, so that's the difference between these. It's still standard deviation. This one's sample, and the other one is population. It's still over the square root of n.
Okay, and what are the key words to know the difference? Is it the confidence interval for the population mean? Is that?
Sample standard deviation, T alpha 2 times S over square root of n. Every time, if they give you the sample standard deviation, you have to do, and so this is no sigma, no population standard deviation. Okay. If the only thing you have is the sample standard deviation, you have to do this process. Now, I'm going to switch this to 95 because we just did a problem with 99, and that isn't beneficial for you to have the same confidence intervals. Okay, so we're going to look at this problem. Sorry, I'm adding a note in before I'm adding that I'm going to make that slide 11 before I move on to the next page for notes. Okay, so let's write down the information as we know it. A sample of 263 students, so n equals 263. We're taking online courses. We're asked to describe their overall impression of online learning on a scale of 1 to 7, with 7 representing the most favorable impression. The average score was 5.53. So average 5.53. And the standard deviation was 0.92. Now, it does not say population standard deviation, and it doesn't say known standard deviation. So we have to default to it being sample. If it does not specifically say population standard deviation, then you have to assume that it's from the sample. Okay. And the confidence level is 95%
I knew that.
for the population mean score. Now, we need to come up with a T alpha 2 value with the area and the degrees of freedom. Please try doing this on your own and enter the answer into the chat for me, privately to me, so I can see it and see if you're correct. But knowing that your confidence level is 95%, that your sample size is 263, what would be your T alpha 2 from this? I understand that some of you do not have it. So you cannot do it, okay? So just hold tight.
I'll just use a bathroom then.
There you go.
I'll try to use. You want the confidence interval?
I want, not the final answer. I would just like to know what your T alpha 2 for this is. I already have one answer and it is correct. Okay. So I had several, almost everybody. Hold on. So we did it. So we did area 50 plus 95 divided by 2. Remember, you're only taking 95 and dividing by 2. So if you want to put parentheses, you can put it around this part, but not the whole thing. So we get 97.5 and we turn that into 0.975. And our degrees of freedom were 262. So our T alpha that we get is 1.969. Excellent job to those that got it. I think I wrote back yes to them, hopefully. Okay. Now we have margin of error equals our T alpha 2 times our sample standard deviation over the square root of n. 1.969 times, what is our sample standard deviation?
.93.
Thank you. 0.92 over the square root of
93. Oh, 92.
what's our sample size?
263.
263. Thank you. When I multiply that across, what do we get?
Zero 0.112.
Yes. The actual answer is 0.1117000642. Okay. But that rounds to three decimal places. The 7 tells the 1 to go to a 2, so 0.112 is your answer. Did anybody not get that? Okay, so now we have the confidence interval. We take our mean minus our margin of error and our mean plus our margin of error. What was the mean in this problem?
5.53.
Right? Minus 0.112 and 5.53 plus 0.112. $5.418, 5.642. Okay. We are 95% confident that the true population mean is between 5.418 and 5.642. How are we feeling on this? It's a lot of steps, right?
But it's
Hell
easy though.
no.
Do you guys
I
want to
feel
make it a bit
fine.
simpler?
I feel fine. I just feel a little handicapped with the no first part, but it's fine. We'll figure it out later.
Well, how about this? I'm gonna pull this guy forward. Okay. And hopefully you can, sorry, I'm trying to make it so it's not too many things on your screen, but you can still see the problem. Does that work? Is that too small?
Oh, I can see it fine.
Let me,
I just don't have the INVT
Why?
on my calculator. That's just my only problem. I knew exactly what to do, but I was like, I hate this.
well, I'm gonna make it a little bit easier for everybody. Easier, maybe. Okay. So we did something on Thursday where we entered the data into the set, right? And we did the Z interval. Do you guys remember that on Thursday?
Yeah.
Maybe. Well, we're doing T alpha now. Do we see a T interval on this?
Yeah.
Number 8.
Number 8. Let's go down and look at number 8 and see what it has for us,
I
okay?
can't believe I missed that.
So now we're on it. Do we have any data that we're entering into a list? Did we enter any data? into a list?
Probably.
Yeah. Uh-huh.
We didn't enter any data into a list, did we?
Nope.
But we do have statistics from the problem, don't we?
Mm-hmm.
What's the mean of the
Maybe.
problem?
So we just kind of fill in the blanks from the problem into the calculator, right?
Yes. What's the mean from this problem?
I really wish I was able to define this at will, but the mean
So-
of this problem is, well, it's talking about the population
Two, 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 three.
mean, but I think there's a normal mean is 5.53.
No,
Yes, 5.53, exactly. And what is the sample standard deviation from this problem?
0.92.
And what is our N?
N is sample 263.
6.3. Oh, if I can enter it, right?
And
Okay,
we already have our 95% confidence interval there.
yep, calculate. Is that what we
I-
just found?
I told you I sometimes know what I'm doing.
No, I think you know what you're doing more often than you.
For Marty,
on.
I
Yes.
think that I'll feel better about doing this once I figure out the other one because I'll feel like it'll justify this. Like I didn't do all
Ah.
that for no reason. You know what I mean?
Right.
So I'm gonna
So
like
here.
punish myself.
Oh, so here, do you see the confidence interval? Did they get the same confidence interval that we got?
Yes.
Yes, they did. Did
so
they
this
have,
is like this is like a cheat code, right?
this is how you can do the entire homework. But here's the trick. Okay, when I have it, okay, if I entered in all of this stuff, right? I still need to find the margin of error. If I'm just given the confidence interval and the mean, how can I find the margin of error? We've done this before. We did this when we started confidence intervals. We did this for 8.11 and 8.12. How do I find the margin of error if I'm given the confidence interval? Yes, exactly. Do you see what Abby texted into the chat?
Yes.
Okay, so it's upper minus lower. Don't forget that that has to be in parentheses if you're entering it just like that into your calculator. Other way, divided by 2. So what is our upper in this case?
5.6017.
What is our lower?
The other one,
The other one.
5.18.
By
Big
default,
brain error.
the other number. And then if I divide by 2, what do we get for the answer?
Okay.
Hmm,
I forgot to put in the parentheses. I have to do it all over again.
Zero point.
Wait.
Okay.
There you go.
Yes, 0.1117, which by rounds is 0.112. And if I show you from before, okay, is that the exact same margin of error that we got before? Yes, it is.
Woohoo.
Okay, so let's do, I see our time. I'm aware of the time, okay? So let's do movie lengths. Please use your calculator and tell me the margin of error.
Wait, what did you get for the margin of error for the last one?
0.1117, which rounds to 0.112.
I did not get that.
Here, Eric, can you see me small in the corner?
Hold on.
Oh, okay.
I am in the
I'll just do that
progress
then.
of plugging this in.
'Cause I put them in parentheses and I don't think that helped that. I see now.
Okay.
Thank you.
Mhm. Mm,
Did I say that unmuted?
no, you did not. You just said, did I say that? Unmuted, but I didn't hear anything before that.
Okay.
Now, can you do this for all of them?
What do you mean?
Like for what we learned today?
Yes.
Oh, okay. All right, thank you.
And I'll tell you, the homework for tonight is actually, if you get them both parts correct, it's only 2 problems. like if you get something wrong. But when I go through and preview, it says like how many times, whatever. And then it only gives me 2 as a preview, and then it boots me out.
Sometimes when I'm stuck, I purposely put in wrong answers just so I could see like what they would give me. So, like they would like explain it in a different way.
Okay,
So if you ever see that, that's why.
that's okay. I mean, everybody has their own thing.
Yeah, I do that sometimes too. Mutually assured destruction, but in the end, you win.
Oh no, yeah, the mastery just does not move.
No.
I've even reached the point where they're like, so you've been getting all of them incorrect. So would you like a tutor? We could suggest these people that you could go to, like the feedback thing.
That's awesome. It's like the opposite of what you tell you to do as a teacher. Like try and get them as best. It's funny because some of my other students, my other class, are like, we don't want to get them wrong. So it takes us a while to work through the problems because they're the opposite. They're like, we don't want to have this happen to us.
Yeah, the second chances have really saved me a lot of times. Like if you get it wrong once, they're like, you want to try it again?
Yes.
And you feel the program looking at you sternly, like, you want to try that again?
Yeah, if only they had one of those. You know how like Apple has the face emojis of people,
Yeah.
like with the expressions and everything. If only
Mhm.
they had one of that.
I think it'd be better if they had voices like The Godfather, where they come in, be like, "You want to try that again, punk?" That'd be much better. Or you can like make it to whatever voice you want to have it as.
Like, make it a British lady
Yeah.
screaming at you.
It's funny.
Sorry about my absence. I was just taking care of my dog.
Okay.
This one.
Okay, there we go. So I'm going to show you the calculator. So if you went to stat and you went to tests, you went to number 8. Stats, you should have 111.7 for the mean, 13.8 for the sample standard deviation, 45 for the N. Rafe, is that your dog?
Yeah,
Didn't you have a black one the other day, or do you have 2?
I have 2 dogs.
Oh, okay.
I was just showing that because when I said that I'll be back earlier, this dog isn't exactly a puppy. Sandy is like a senior, so sometimes I have to take care of her. You understand? I just
You were
wanted to
absolutely correct.
explain why I was gone,
Okay.
why I left. It's just
Thank you.
saying my dog basically.
Yeah, you got to make sure. So there's your confidence interval, but they're not asking for that. They're asking for the margin of error. So you would take your confidence interval and subtract the lower from the upper and then divide by 2. And you would get 3.69 to be your margin of error. And then your confidence interval, which is asked for you on the second step of the problem, is already there. Any questions on this? Now I'm going to double share and erase all this so you can see it. You probably aren't going to see problems like this, but just in case. Okay. Now let's look at the next one. Cereal box weights. Boxes of cereal are labeled as containing 14 ounces. Following are the weights in ounces of a sample of, oh, sorry, Abby, did you see the answer? Okay, she's got it. Okay. It is reasonable to assume that the population is approximately normal. We have the data listed. construct a 95% confidence interval. Based on this confidence interval, are the boxes labeled correctly? Now, when I see data, what do we have to do with it?
Enter it into stat, edit.
Yeah.
Into L1, right? So let's enter this data into L1. So stat list, make sure you clear it first. The reason I say to clear it instead of just writing over it is because the new data that you're putting in might not be as long as your old data. And you will be left with miscellaneous numbers, which will throw off your answer. Now, while you're entering that in the problem, did it give us a population standard deviation?
No, no standard deviation.
No,
No. Did it give us a sample standard deviation?
negative.
It did not. So we don't have either one. And if you have neither one, you're still going to have to do a t-interval for it. Okay. When we were doing this on Thursday, we did z-interval, and I'm going to show you the z-interval for the data just so you can see it. It asks you for the population standard deviation. I do not have that, so I cannot perform that test.
Mhm.
I have to do the z-interval and data, because the only thing on the z-interval that it wants is to have my data listed and the confidence level. Our confidence level is 95. Our list is L1, our frequency is 1, 0.95 will be our confidence level. We hit enter and we calculate. And it gives us our confidence interval, and we could take that and work backwards if we wanted to for margin of error. I will do that quickly. So we would say the 14.104 minus the 14.026 all over 2. Okay. Yes. And then you would get 0.039 for your
I'm sorry, I was a little slow to find it because I kept on clicking on the wrong ones.
Oh,
What did
okay.
you put in for frequency and sea level real quick?
Frequency, it could be blank or 1.
1, and then for what was the?
Oh,
What was
it was 0.95.
Okay. All right. Thanks.
Mhm.
I got an error message, but
Oh, maybe you didn't go to stat, go to
Mhm.
tests, go to number
Mhm.
8, and then let me see what your screen says.
Okay, my number 8 is that.
Yeah, and hit enter.
Okay.
And let me see that. Oh, it's because your frequency of Y.
Oh,
So just hit clear there
okay.
and then try it.
Okay. All right, we're Gucci.
Okay.
That was the first
So
time.
you don't have to put in the confidence level.
Yes, you did. We had to put the 0.95. He had already put that in for his.
Okay.
Okay. Yeah, sorry, let me go back to my, so you can see that I put it in. Okay, I had list 1, frequency 1, or that could be blank, but the confidence level is important, and it was 0.95 from the problem. Okay. So we've learned how to do it by hand. We've learned how to do it with the calculator. You can find the confidence interval. Remember that they want to know the margin of error. So make sure that you are doing that correctly. Tomorrow, we're going to learn one more confidence interval and just kind of the discussion board post for this week. I'm asking for the formulas. So you've already seen 2 of them now. It's the X bar plus or minus the Z alpha 2, right? And you've just learned the one today, which is the sample mean, the X bar plus or minus the T alpha 2 times S over the square root of N. So those are the two of the 3 formulas that you need for the discussion board this week. Okay, the other one we will learn tomorrow. You're more than welcome to go ahead and look ahead at the PowerPoints if you want to get that discussion board done sooner. I'm going to stop recording. Actually, hold on, that's stop recording. Tomorrow we're covering the last confidence interval. Wednesday, we are going to do the big review. Thursday is the test. So it's going to be another one of those where we do not have lecture on Thursday, but you have from midnight to midnight to take the test. Okay, now I will stop recording.